Good morning, Mr. Crowley here, and I want to take 5 minutes or less, because that's all the time they give me on this one. 5 minutes to go over very quickly, review different ways that reaction rates can be increased. We talk about this in terms of rates of reaction. So there are several things that we'll talk about, and I'm going to review the examples that we've been given and what we've done in class. But first and foremost, remember, in order for chemical reactions to occur, atoms must collide. You've got to have collision, and they've got to collide with enough energy to allow the reaction to occur. If they don't collide with enough energy, nothing's going to happen. Now, one of the ways we can increase and help out this rate of reaction is by increasing the temperature. Case in point, do you remember when we had the two identical light sticks? We cracked them. We set them in two beakers of water. One was room temperature water on the cooler side, and one I took off the hot plate. If you remember, the glue stick that was in the hot water glowed with a much more luminosity, with a much greater brightness. And that's because temperature increased. The hot water allows the particles inside here to move faster. They move faster, they collide more often. They collide more often, the rate of reaction goes up. Here's another one. Do you remember when we took cornstarch and we had it in a little pile? We had it in a pile. And then I blew the cornstarch out into the flame. When I blew it out into the flame, we got a boom. Now, why did that happen? We increased surface area. When we increased the surface area in our cornstarch, see here, it was all packed together. It was on top of it, just sitting in a pile on a piece of paper. And I tried to light it. If you remember, I put the flame right on it. Nothing happened. And then we blew it out over the flame, and then boom. Remember, we didn't see one big explosion. We saw thousands of tiny cornstarch grains explode, combust at the same time. We talked also about another way to increase a chemical reaction, and that would be to add a catalyst. Well, if I add a catalyst, that means I'm adding a chemical to help my reaction go faster. Here's a battery. Here's salt water. Now, if I put this battery in the salt water, you can probably see that this is really reacting. This is called electrolysis. Well, this is H2O, and it would do this anyway. But when I put the salt in there, it gives the electricity an extra bridge to move through. So the salt acts as a catalyst, and this bubbles right here, these bubbles here, that's hydrogen, because there's twice as much hydrogen coming off of here as there is oxygen on the other side. So the way we can increase rates of reaction are increasing temperature, increasing concentration, putting more of the particles in there. Instead of 1 teaspoon of salt, maybe put in 3. Might be overkill, but we can increase temperature, as I said. We can increase surface area. We can increase concentration. We can add a catalyst. We can also add pressure. If I have a bunch of molecules and I want them to react or collide more often, I will put some pressure on them, forcing them together. When I force the molecules together, they got no choice but to collide. More collisions, more possible energy, more chemical reactions. And this energy that these particles need, the energy, we call that, it's got a really special name. It's called activation energy. I'm guessing because it activates the chemical reaction. So let's recap. If we want to effectively change, or in this case, increase our chemical reactions, we can increase pressure or concentration of the particles, increase temperature, increase surface area, or add a chemical catalyst that speeds up the reaction, in this case, but it doesn't affect it, doesn't change it or mess with the outcome.